Hey class, today we're going to review Newton's laws of motion, and we're going to apply those to explain how the sun, the earth, and the moon all move. So first off, I'm using the PhET simulation here, and I just want you to get a picture of how vast and huge our solar system is. That star you are seeing in here is a representation of the sun, and this planet is the earth. And look at how much space is found between those. So I'm just going to let the simulation run for a little bit. How long do you think it takes the earth to orbit the sun? We got close there. Um, the number I show there is 360. You might know, and hopefully you do know, the exact number that it should be. Now I'm going to change it and add a picture of the Earth and the Moon. And this dot here is representing the Earth. Here is the Moon. How long does it take the Moon to orbit the Earth? It hit pretty close to there as to where it began. You might know what is the significance, and hopefully you do know what the significance of that number is. Next, I'm going to show you a picture of the Earth and a satellite, something we might use for GPS or other devices that so that we can send information up into space and then back down. And I just want you to notice how big the Earth is compared to that satellite. Now that you've got a picture or understanding of how big the solar system is, and that's just a small part of it. Remember, the Earth is the third planet from the sun. So if you would go on to the rest of the planets in our solar system, it would be vastly bigger than that. First thing I want to focus on is Newton's first law of motion. And to show that, I'm going to decrease or eliminate the force of gravity here. So let's say there was no force of gravity. You could see the Earth here. Our Earth at rest would stay at rest until an unbalanced force acts on it. That's Newton's first law of motion. And once the Earth is in motion, it wants to stay in motion at a constant velocity until an unbalanced force acts on it. So first of all, I want you to know that somehow the earth had to get in motion. As Christians, we know and believe that God created the universe and he set the planets into motion. And that's one reason that those who reject that creation account had to come up with some other um, theory as to how the earth and all other objects in the universe got set in motion. And that's one of those theories is the Big Bang theory, that an explosion got everything into motion. So, but I'm going to eliminate the force of gravity here, a gravitational force, and I want you to watch what happens. So an Earth in motion would, until let me reset that now. But we know that there is a gravitational force, and so I'm going to represent that. And that gravitational force is going to be the unbalanced force that causes the Earth to accelerate. Acceleration, remember, is any change in velocity. Usually we think of that as something speeding up or slowing down, but it could also be a change of direction. And so in this case, the gravitational force on the Earth by the sun is going to cause the Earth to change directions. Instead of going straight, like it wants to. The red arrow is representing the velocity that it wants to go. That's the inertia would have it go this way. But then there's going to be an unbalanced force, which is causing it to change that direction. What do you notice about the direction of the gravitational force? So we could do some calculations. Newton's second law, remember, is acceleration equals net force divided by the mass. We could calculate the size of the gravitational force by the sun using Newton's universal law of gravitation. And we could find the mass of the Earth as well. And if we would take that gravitational force by the sun divided by the mass of the Earth, we would get the acceleration of the Earth. That's Newton's second law. Newton's third law. What do you notice about the gravitational force on the Earth by the sun compared to the gravitational force on the sun by the Earth? The simulation doesn't show it real well, but the Earth does accelerate as well. It's moving as a result of that gravitational force. And the sun also moves as part of the Milky Way galaxy, revolving around the center of that galaxy. Let's add the moon in there so that you can see all of them. I'm going to get rid of the velocity just so it's not too cluttered. Right, next I'm going to switch to just the motion of the Earth and the moon. What do you notice about the gravitational force on the moon by the Earth compared to the gravitational force on the Earth by the moon? Those are represented by those blue arrows. Again, if we would take gravity off and set the moon in motion, a moon in motion will, until but we do know there is a gravitational force. Once again, we can figure out the acceleration of the moon, the change of direction by taking the gravitational force on the moon by the Earth and dividing it by the mass of the moon. You can see a little bit here, that circle in the middle is showing that the moon is actually moving, or the Earth is actually moving as well as a result of the pull of gravity. You may also know that some of the other effects of the gravitational force on the Earth by the moon would include the tides, where the moon is actually pulling the water on the Earth towards it as it goes around. So once again, we saw three examples of the Newton's three laws of motion. A Earth or moon that is in motion will stay in motion at a constant velocity unless acted upon by an unbalanced force. So that's why it's very important that God designed a gravitational force to keep us in orbit. And also we also know that God set the planets in motion during the days of creation because a Earth or moon at rest would stay at rest until that unbalanced force would act. We can calculate the acceleration of the moon or the Earth by taking the net force, that's the gravitational force acting on it, divided by the mass of the moon or Earth. And forces always come in pairs that are equal in size and opposite in direction. So the force with which the sun pulls on the Earth is equal and opposite to the force with which the Earth pulls on the sun. And the force with which the moon pulls on the Earth is the same as the force with which the Earth pulls on the moon. Forces come in pairs.